Now let's start writing the code of our program. First of all, you need to install the C++ development environment. It's already installed on this device, but I will show you how are you going to install it on your device. You press here on extensions and then search for C++ in the marketplace. You'll find it here and click on it, then click install. It will be installed and then you can work with the C++ development environment. Now we are going to create a new folder or open a folder and create a new folder, C++ solving system of linear equations, and select folder. Then we are going to create a new file and, for example, name it source.cpp, which is the extension of a C++ file, and press enter. First of all, we need to start by including some outside libraries which contains functions that we are going to use. So the first library we are going to include is the IO stream, which includes functions that are used in order to read or write to the standard input-output streams function like cin and cout. The second library is the stdlib.h, which includes function involving memory allocation, process control, conversions, and many other functions. And the third function is stdio.h, which includes function as printf and scanf. And then we are going to include the string to use strings and vector and ssstream, which provide templates and types that enable interoperation between stream buffers and string objects. And io main IP and mass.h, and this mass.h contains the basic mathematical operations. And the last one is used mostly by MS-DOS compilers to provide console input and output. And the last thing we need to add is using namespace std, which enable us to write methods which std library includes without writing std double colon before it. For example, we'll just write cout instead of writing std double colon and then cout. Then now after we included the libraries we're going to use, we need to declare our main function. So we come here in main and press enter. You'll find that it will be formed automatically, and you find int argc and the pointer to the array argv. Argc is the number of arguments that the user passed to the program while running it, and argv is pointer to the array which contains our arguments. To make sure of this and understand what is the arguments and how and what is argc and argv, we will see out argc and a dash and argv of 0 and another dash and argv of 1. Then let's try building this and run the program and see what the output will be. First, you need to run build task to create our JSON task, the JSON file. So we said create task JSON file, and for our purpose, this is we are going to use others, and the task.json will be created. I will come back here and view the integrated terminal, and here we're going to compile this program using the GCC compiler. So the command line will be like this. Just make sure that you save the file so it will build correctly, and press enter. So build successful. Then, for example, if we pass for the program source and then 3 and press enter, so the output will be 2 source and then 3. 2 is the number of arguments, which is argc, and source is the first argument, which is argv of 0, and 3 is the second argument, which is argv of 1. We are going to use this second argument as the number of equations in our case. So if the user passed to the program source and then 3, this means that he is going to form a system of linear equations which consist of 3 equations. So let's work on this. First, we're going to erase this line, we don't need it, and we're going to declare count, which equal to argv of 1. But we need to convert this from char into int, so we're going to use this function. And if count is less than 2, we'll just return 0 because there is no solution for only one equation. And the other case, if count is equal to 2 and equal to 3, this means that we have an equation and we need to take the input or the equation from the user. So we are going to make a for loop. I is less than count and I plus plus. And at each iteration in the loop, we need to take an input from the user. So we'll give him an output, enter equation number, and the order of the equation is I plus 1, and give a space between the output and the input. And we're going to store this in equation, which is a variable where we will declare here. Let's first try this and see if this is going to work, then complete what we started. So we need to rebuild this. I'm going to use the same command and source and then 3. You found that the program gives you an output, enter equation number 1. So for example 3x plus 9 is equal to 2y minus 7z, and we can use the same equation to save our time and enter equation number 3. So now everything is working fine. We took our 3 inputs. Now we need to do our work on this equation. First of all, we need to divide this equation into 2 sides, left hand side and right hand side. For doing this, we'll create a new class, the equation class, which is role is to divide the equations. So we come here and create a new class. It's a public class, and we create our constructor, which will take string eqn. Now to split these equations into left hand side and right hand side, we need to know the index of equal to split on it. So we come here and say int equal index is equal to eqn dot find equal. And after we found the order of equal, now we can divide the equation into left hand side and right hand side. So we're gonna give an output for the user with the left hand side and the right hand side. So we're gonna come here and say cout new equation, and line, and another cout left hand side, and the value of left hand side is equian dot substring from 0 till equal index, and line, and the same for the right hand side. I just change this, and it's equal to equation that substring from equi-index plus 1 till the end of the string. Let's try this and see if the output will be right. So we rebuild this. Okay, build is successful, and source, and then 3, and take the same equation. Okay, we missed something. We need first to create an instance from this class and pass it to it. So first we need to create a new vector of equation, and name it equations, and here at this equations we will add all the input equation, pushback, and create a new instance from the class and pass to it our input. So now this is going to work the same, but after the change, suppose that everything will work. Let's try this. I'm gonna rebuild. Okay, you build is successful, and then source 3, and then press enter. Now here's it, the output we were expecting: new equation and the left hand side and the right hand side. Now after we divided the equation into left hand side and right hand side, we need now to divide each side into terms. So to do this, we need to declare a new class, which is the equation side class, which its role is dividing the side into terms. So we're going to come here and declare a new class, equation side, and it's a public class, and it contains function which is set side. In this function we are going to split each side into each side into terms. So it's going to take string side, and we're going to work on this side. For example, if our side is 3x plus 9 as our case, so the terms of this side is 3x and 9. How are we going to split this into terms? First of all, we need to split or to divide when we found a plus. So we will iterate on each character of the side, and when we find an operator, a plus or a minus, we will divide as we at this point we found our term. For example, when we iterate on this, add the first characters 3, no operation, the second character x, no operation, then positive, this is an operation or this is an operator. So what the 3x is now our first term. See, we're gonna take this, and this is our first term, and positive will be the sign of the upcoming term, and iterate on the rest so we found 9 and then the string is ended, so we will add the other term which is 9. Let's see how are we going to do this using the code. First of all, we need to define string current term, which we are going to add in it the term, and string temporary operator, and we will add in it the positive sign, because for example at the start 3x plus 9, when we first found an operation, it will be the plus between 3x and 9, this plus, and this plus represents the sign of 9. So what is the sign of 3x? It's positive, but it's not written, so we need to add this as a constant value to be added when there's no sign is written, or in the first value in the first term which is contains no sign. And if the first term is a negative sign term, then the negative sign will be present in the term, so we'll work on it. So let's complete what we were working on, and now we define int I and iterate on each character in the string. Add our semicolon on this. So here at each iteration we're gonna make an if condition to see if this character is an operator or not, or it's a plus or minus or not. So on a plus or side as substring is a minus. Now if you found an operator, so he will add if current term is not equal to an empty string, we will see out to the user the temporary operator and then current term and end line. This what we will do in the case we'll find an operator, and we will just add the new operator, which is the operator of the coming term in this variable. So it will be side the substring of I and 1. And then we will empty the current term to store in it the new term. But in the case where the character is not an operator, it's not a plus or a minus. So in this case, we want to add all the characters on the current term string to form our term. For example, on the first character, which is 3, is not an operator, so we'll add it on the current term. The second character is x, so we'll add it on the current term. So the third character is positive, so at this point the current term will be equal to 3x, which is our first term, which we will give it as an output to the user. So we come here and just say current term is equal to current term plus side dot substring of I and 1. Now I think we finished. Just we need to add if the last term, when you come to the last term, we won't found an operation after it, but it already existed and we need to add it. So if I is equal to side.length, which means we get out of the loop, then and current term contains a value, it's not equal to an empty string, so we need to add this output temporary operator and current term and end line. So we come back here to the equation and create two instances from the equation side class temporary left hand side and temporary right hand side, and here we say temporary left hand side dot set side and pass to it the string which contains the left hand side, and then temporary right hand side and pass to it the string which contains the right hand side. And for things to be clear, we can do this left hand side terms and end line, and here right hand side terms and end line. Let's try this and see if the expected output is right. So first we need to complete this and rebuild. Okay, we got an error, so let's see what is it. Okay, this need to be changed. I've still got any error, and here the same problem. Okay, now there is no errors. Let's try to rebuild. I'm still facing an issue. No, I don't know what it is. Okay, here build is successful. So let's try rerun this and get our equation. Let's scroll back. So here's it. The expected output left hand side terms is positive 3x and positive 9, and the right hand side terms is positive 2y and negative 7z. Now we need to work on these terms. We need to define the sign, the coefficient, and the unknown for each term. So to do this, we will define a new class, the terms class, which is a public class, and set our constructor, which will take a string term. Now what are we going to do is to search, to iterate on each character in this string. until we found an alphabetical character, or for example X or Y. So at this point we found our unknown, and we can at this point define our coefficient and define our sign. By the way, the sign need to be passed to the constructor here. Okay, and we need to define some things here. String unknown, and float coefficient, and string sign, and string term. So now we defined everything we are going to use. So let's start. First of all, we'll say term is equal to term, and sign, capital letters, is equal to sign. Then we need to work to find the coefficient and the unknown. So we're gonna make our for loop, and I is equal to 0, and for just int I, and for I is equal to 0, I is less than term length, and I plus plus if this term of I, or this character we are iterating at, is alpha, we will break at that point. So we found the order of the unknown, and the coefficient will be equal to, sorry, and the coefficient will be equal to term dot substring of 0 till I. We need to convert this into float, so we're gonna use these two functions to convert it. So for example, when the past term is 3x, so when we iterate on this, the first iteration, the if condition won't be true because 3 is not an alphabetical, and at the second iteration it will be true. So we found the order of x, it will be at I is equal to 1. So this means that the past characters is the coefficient of the term, which we will add it here. Just a last thing we need to add is our unknown, and we need to handle something. If I is equal to 0, which means that the coefficient is equal to 1. How this? For example, if the term is x is a term which contains no number written beside it, but the coefficient still exists, and it's equal to 1. So we need to handle this case. If I is equal to 0, then coefficient is equal to 1. Then we need to define our unknown, which is equal to term dot substring from I till 1. Now we defined everything. We just need to add something which will help us during solving the system of linear equation during using Cramer's rule. We need to come here and declare a new vector of string unknowns and store in it all the unknowns of our equations. But we need to store in it each unknown for one time. So to do this, we're gonna define int flag is equal to 0, and if unknown is not equal to an empty string, which means our term contains an unknown, then we will loop on the vector of strings unknown. So for int I is equal to 0 and I is less than unknown dot size and I plus plus, we need to make sure that this unknown is not already added to the vector. So if unknowns of I is equal to the unknown of this term, then change flag to 1 and break, and then we will come here after the for loop. If flag is equal to 0, which means that this unknown doesn't exist, we need to add it to the vector. Now I think we finished defining our terms, so let's go on the upcoming part. We need to work on each side. For example, if our side is 3x plus 9 and the other side is 2y minus 7z, all the terms which contains an unknown must be in the left hand side term. For example, if this is our equation 3x plus 9 is equal to 2y minus 7z, then we need to get these two terms to the right hand side to the left hand side and change their signs, and this constant term get it to the right hand side and change its sign. So let's see how are we going to do this. First, before doing this, we need to add here, we need to create a new vector of terms, temporary terms, and here we will call the terms class. So the function will define our class terms, and it will take current term and temporary operators, and the same thing will be done here. So here we called an instance from the class terms to define the coefficient unknown and sign of our term. Now let's go back to what we were going to do. We come here in the equation class and we need to iterate on the terms of the left hand side term. If we found in it any term which doesn't contain an unknown, we need to add it to the right hand side. To do this, we will create two new instances of this class to add on it the new terms after our change. So we'll add our for loop for int I is equal to 0 and I is less than temporary left hand side dot temporary terms dot size and I plus plus. If temporary left hand side dot temporary terms dot unknown is equal to an empty string, then we need to add it to the right hand side after changing its sign. So if temporary left hand side the temporary terms of I dot sign is equal to negative, then we'll define a string operator here to work on it. String operator, then string operator is equal to positive, and we'll add else if it's positive, change it into negative. And after changing the sign, we will add it to the new right hand side. The temporary terms dot pushback terms of temporary left hand side dot temporary terms of I the term and operators. Now suppose that everything is working fine. I'm just having a problem here with this terms of I s dot unknown. Okay, now we don't have any problem. And else if it contains an unknown, so it will be added to the left hand side or the new instance left hand side, and the operators won't be changed. Now we need to do the same loop but on the right hand side terms. So we'll iterate on the right hand side terms, and if unknown not equal to an empty string, then we need to add this to the left hand side after changing its sign. So we change the sign, and here we will add this to the left hand side, and here we'll just add it as it is to the right hand side when the unknown is equal to an empty string. Now I think we finished. We just need to do something else on the equation. For example, if our equation is equal to 3x plus 2x plus 4y plus 7z equal to 10. These two terms need to be added as they both of them contain the same unknown. So we need to add a reduce function for doing this. We will add it in the equation side class. So we come back to the equation side class and create a new function, void reduce. In this function we need to iterate to see if an unknown exists in a side for 2 times, or for example in the right hand side if we have 9 minus 3, so this also need to be calculated. So let's do this. We will declare int flag and iterate on temp terms dot size and j++. We need to create a new vector of terms and name it current terms to add on it the new terms after calculating or adding or minusing the terms which have the same unknown. So we come here and at each term we're gonna make an if condition. If current terms of we need to do another for loop. We set flag is equal to 0 and do another for loop. Int I is equal to 0 and I is less than current terms dot size. We will make an if condition if current terms of I dot unknown is equal to temporary terms of j dot unknown, then in this case we need to add the coefficients. But before adding the coefficient we need to take in consideration if the sign of this coefficient is minus. So we come here and make another if condition. If current terms dot sign of I dot sign is equal to negative, then in this case current terms of j dot coefficient is equal to -1 multiply current terms of j dot coefficient, and the same for the temporary terms. If temporary terms this need to be I, if temporary terms of j dot sign is negative, then temporary terms of j dot coefficient is equal to -1 multiply temporary terms of j dot coefficient. Then after we change the sign, now we will add the two coefficients. So current terms of I dot coefficient is equal to current terms of I dot coefficient plus temporary terms of j dot coefficient. And change flag to 1 and break. So if then after the loop we come here, and if flag if still equal to 0, which means that there is no term with this unknown already exists in the current terms, so we need to add it. So current terms dot push back terms of temporary terms of j dot cof dot term and terms of j dot sign, and Alt Shift F. I think now we finished all the work we need to do on the equation. So let's display this equation after we finished all the work and see if everything's done right. So first of all, we will declare a new class, utility class, where we will add some functions which we are going to use all over the project. They are not related to each other, but we can add them all in this class. So public, and our first function is the display equation. Static void display equation. And at this display equation, remember that all the equations are already stored in the vector equation, these vectors. So we can iterate on it to view our equation. So here we set for int I is equal to 0 and I is less than equations dot size and I plus plus. Then we will iterate on first the left hand side terms for int j is equal to 0 and j is less than equations I dot current term or the left hand side dot left hand side dot current terms dot size and j plus plus. Then we will see out to the user equations of I at left hand side current terms j dot coefficient, and then dot unknown. But first, before adding the coefficient, we need to make an if condition in case that this term is not the first term or its sign is negative. We need to add its sign or to print out its sign. So if j is not equal to 0, or equations of I at left hand side at current terms of j dot sign is equal to negative, then in this case we need to do this output equations. Take this copy to save time, and we will do the same but for left hand side and add equal between them, and take this copy. But sorry, all of them are here inside this loop. The difference is that here we are going to work on the right hand side, and we're going to do the same, nothing changed. So here we define the class. I don't know what's the issue here. Okay, this is static. 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 Okay. Now let's display our equation and see if everything is done right. So we come here. I don't know why this is current terms. Yes, this is another issue. Actually, the entry sense is a double agent. Okay, now everything is working, and here we are going to call this function utility and double colon display equation. Now let's rebuild this and see what would happen. I just need this equation to work on. Okay, build is successful, source and then 3, and then the left hand side we need to give it all the equations. Okay, it didn't work right, so let's see what is our problem. Here we're working on the equation on the left hand side with current terms. You just need here Yes. After this, we need to add these two. And the reduce here will add this to the current term. Still having a problem. Okay. Let's rebuild this and see what would happen. Get back our equation. Yes, here's the equation. After, well, yeah, we need to end line. So see them clearly. Okay, rebuild source and then 3. Okay, here's our equations. I did everything right. I just don't know why we haven't seen this. We need to resave. Rebuild. Sorry. That's the equations. So here our 3 equations. After we done all the work, the terms which contains unknown is now added to the left hand side, and the terms which is the constant term is added to the right hand side, and the signs are changed. So now let's work to form our matrix. We will form 2 matrices, the default matrix and the variable matrix. The variable matrix is what we already explained in the first of the video. It's equal to the default matrix. What we replace the column which is order is equal to the order of our unknown by the right hand side matrix. So let's see how are we going to do this. We will come here in the utility class and add a new function, set matrix. So here static void set matrix, and we need to add 2 more vectors to add in them the left hand side matrix and the right hand side matrix, but the left hand side matrix need to be stored in a 2-dimensional vector, and the vector is of type string. For example, name it coefficients, and vector of string, we can name it right hand side matrix. This is coefficients matrix. So here we will also iterate on the vector equations which contains all the equation. and declare a new vector, one-dimensional one, coefficient. So this will be a float, not string. I missed this. So now we will also iterate on the unknown vector which we formed earlier in the terms class. We will iterate on each unknown. For example, the first unknown is x. We will get the coefficient of x in the first equation, then in the second equation, third equation, to form our matrix. So let's do this. First, if unknowns of j is equal to equations of I dot left hand side, and of course we are working on the left hand side because it's the term which or the side which contains the terms that has an unknown. The current terms. Okay, we need to add another loop to iterate on each term. So for int k is equal to 0 and k is less than equation I left hand side dot current terms and k plus plus. And here if dot unknown, if they are equal, then in this case we are going to add it to the coefficient vectors pushback equations of I left hand side current terms of k dot coefficient and break, and we need to add a flag here is equal to 0 and change this flag here to 1. We're going to use this flag, but before adding we need just to make sure that the sign is not negative, because if it's negative we will need to multiply the coefficient by -1 first before adding it. So if coefficient of k dot sign is equal to negative, then equations of I dot coefficient is equal to -1 multiply okay, and here this is coefficient dot pushback not equal pushback, and flag is equal to 1 and break, and this is current terms term. So now we define this flag. This flag we will use it in order to make sure that the coefficient of this unknown exists. For example, maybe this function doesn't contain this unknown. It contains only two unknowns, x and y, and the coefficient of the unknown z is not present, is equal to 0. So in this case, we'll make an if condition here. Sorry, if flag is equal to 0, then coefficient dot pushback 0. The current terms dot size. Okay, and after we finish this loop, here we are going to add this vector to our main vector matrix dot push back. Then we will work on the right hand side terms. So we'll just take this and it's one dimensional, so we don't need to do all the work we done for the right hand side. Just change this and here, and this is always 0 as it's one dimension, and here change this into right hand side matrix, and this is I and this is 0. So now we finished setting our two matrices. We formed the right hand side matrix and the left hand side matrix. So now let's form our variable matrix. So we'll add a new function here that return a two-dimensional vector of float, which is the variable matrix, and name it get variable matrix, and it will take two-dimensional vector the right hand side matrix. Sorry, this is the left hand side matrix, or we can call it the coefficient matrix, whatever we call it, and the one dimensional vector the float the right hand side matrix. So here we will iterate on the coefficient matrix dot size and I++. We need another thing to be passed here. It's int var, which represents the order of our unknown. This unknown is x or y or z. Its order is 0 or 1 or 2. And here we will change coefficient matrix of I and var. So for example, if we pass 0, we will change the values of the first column with the values of the right hand side matrix, and this variable matrix represent the variable matrix for the variable x, and if it's 1, so we will form the variable matrix for the variable y, and the same for the z matrix. So it will be equal to the right hand side matrix of I and return coefficient matrix. So here we need to call these two functions here. So you come here back to the main, and we will call the set matrix, the set our matrix, and then the get variable matrix we need to loop and get its value at each unknown. But first we need to do a function to calculate the determinant of a matrix. So we come back here in the utility class and add a new function, static void calculate calculate determinant, and this calculate determinant will take a two-dimensional vector of float matrix. Okay, this is not written. Calculate determinant. Yes, I think now everything is fine. Now this is a recursive function. It can calculate the determinant for a matrix of any dimension, of any order. So first of all, we will declare float where we will store the value of our determinant, and if matrix dot size is equal to 1, then return matrix of 0 and 0. In this case, no calculation needed. It's only one-dimensional matrix. Then if this should be static int, not void, because it will return a value. Matrix dot size is equal to 2. Then we will return, in this case, determinant, and determinant will be equal to matrix of 0 multiplied by matrix of 1 and 1. If you don't understand how the determinant of matrix is calculated, you could search for it on the internet to understand what I am writing. It's a mathematical operation and of 1 and 0. This is a cross multiplication and then minus each line. Okay, I think now it's fine. We are getting a right value. Then else, if its size is more than 2, for example 3. Now the case where we will use the recursion. In this case, we need to iterate on the elements of the first row in the matrix, and then at each element we will cancel the row and column it exists in and form a matrix from the rest of the elements. And then we will recall the function and calculate its determinant. Let's see how we're going to do this. When I write the code, you will understand more what I've just said. So we will iterate on the elements of the first row, and p is equal to 0, and p is less than matrix 0 dot size and p plus plus. And create a new vector float temporary matrix to hold the new shape matrix. Then we'll iterate on the matrix elements, the main matrix, which is passed to the function, but we will make sure to cancel the row and the column the element of the first row exists in. We will already start from 1 to cancel the first row, and we will make an if condition to cancel the column it exists in. So here, declare a new vector, one dimension 1 float row, temporary row, where we will store the rows of the new formed matrix, and we will iterate in j is equal to 0, j is less than matrix of I dot size and j plus plus, and if j is not equal to p, which means we are in a different column that the different column that this element exists in. So in this case we will add the element to the temporary row. Temporary row that push back matrix I and j. And here, if after we finish the row, if temporary row dot size is greater than 0, sorry, then temp matrix dot push back temporary row. Then after we iterate and formed our new matrix, we need to recall the function. So determinant will be determinant equal to determinant plus matrix of 0 and p, which is the element in the first row, multiply by this function is used to give us a 1 or a negative 1, as we need to change the sign at each element. In the first row, the first element we need to use the positive sign. The second element we need to use the negative sign. The third element we need to use the positive sign. So we'll use this function to do for us this, and calculate determinant and pass to it the temporary matrix which we just formed. And finally return back determinant after it do all the recursion and finished all the work. I wish this will work, and I hope I didn't forget anything. I'm sorry. So I think now we finished. We will just come back here, and after set matrix we'll get the value of the coefficient matrix. It's equal to utility and calculate determinant and pass to it coefficient matrix which we added in it, and we will iterate on the unknown vector to get the variable vector for each unknown, the variable matrix for each unknown. We'll create here a new vector of float to add the values of the determinant of each variable matrix. Variable determinant. And here we will say variable determinant dot push back and pass it utility calculate determinant and utility dot get variable matrix, and the order is I, and the coefficient matrix, and right hand side matrix. And then we need to give the result as an output for the user, int j is equal to 0 and j is less than variable determinant dot size and j plus plus. So at each variable we'll see out, and just to give 2 lines as a separator between them, and unknowns, see out the unknowns of j, which for example is x, and an equal, and variable determinant of j divide by the coefficient matrix determinant. Let's rename the coefficient matrix determinant, so when you read the code you can understand it. And see out 2 new lines. So voila, we finished. Let's see if something's wrong. Okay. Now everything is fine. We're still facing any problems. This, and this. And the last one. Okay. Variable determine, yes, and here's it, no problems. Let's rebuild this. G++ minus G source. Let's see minus O source and enter. Rebuild is successful. Now source 3 and enter equation number 1. For example, x plus 2y plus 3z equal to -5, and the second equation 3x plus y minus 3z equal to 4, and the third equation equal to -3x plus 4y plus 4y plus 7z is equal to -7, and press enter. So here is the solution for the system of linear equation, which consists of three equations: x equal to -1, y equal to 1, z equal to -2. Now we finished our project. Thank you very much for watching. See you in the next videos. Goodbye.